Hey Zara, so I'm just doing this as a prerequisite to the rest of the calculus we're going to be doing. It's just going to cover a lot of the basics. So if you watch this, it might give you a better understanding. If not, look, we'll work through them week by week, and you should start to get used to, especially with your teaching on through them as well. So start off question 5. It says g of x is equal to x squared plus 1 over x, where x is a real number. Find g prime of x, the derivative of x. Easiest way to do any calculus is to get them all looking like the kind of numbers you're used to seeing. So we can immediately say that g of x is equal to x squared, and then minus 1 over x. Well, if we take x to the negative 1, that's equal to 1 over x. So we just have minus x to the minus 1. So if we replace that, we're going to have minus x to the minus 1. And now we can differentiate as normal. Doesn't matter if the number is negative, it's still going to go down. The only reason the x disappears is if we have x to the power of 1, which then just goes to 1. So, because in that case we'd have 1 times x to the 0. Anything to the power of 0 is equal to 1. So therefore that would just be equal to 1. So we can just find g prime of x straight away, and that's going to be equal to 2x minus, and then we bring the minus 1 to the front, so that changes to a plus, and then we have x to the negative 2. And then if you want, you can rewrite this again as 2x plus 1 over x squared. Part B. F of x is equal to 2x cubed minus 21x squared plus 40x plus 63. X plus 1 is a factor of f of x. Find the three values of x for which f of x is equal to 0. So this is going to be a division one. So we can start off with the 2x cubed, and then we have to divide by x and multiply by 1. So 2x cubed divided by x goes in 2x squared times the difference between 2x squared to get to minus 21x squared. Well, that's minus 23x squared. So this goes up here. I'm sorry, up the very top we're going to have our 2x squared because that's our first division. Now we divide by x, so that goes in minus 23x times the difference between minus 23x up to 40x. Well, that's going to be equal to plus 63x. So we've plus 63x here, and then we can bring the minus 23x here, which we got from the bottom row in the middle. 63x divided by x, that just goes in 63 times, and that's going to be our final number. So it's going to be 2x squared minus 23x plus 63. So we have 2x squared, or minus 23x plus 63. So now we just need to find the roots of this, and you're going to be using the roots. That's just going to be your minus b formula. Two times a. So then we're going to have 23 plus or minus the square root of minus 23 squared minus 4 times a, which is 2, times c, which is 63. And this is all going to be over 2 times 2. Two values for this. One's going to be positive, one's going to be negative. So if we work that out, if we do plus, we get 7. And if we do negative or minus, we're going to get 9 over 2. So that means that our three values are x. Well, the very first one was we had x plus 1 as a factor. So that means that x is equal to minus 1. So we have minus 1, we have 7, and we have 9 over 2. There are three roots. Now, find the range of values for x for which f prime of x is negative, correct to two decimal places. So first of all, if we take our f of x again, I'll write it in blue just so you can see at the top. This is going to be equal to 2x cubed minus 21x plus 40x minus 21x squared, sorry, minus 40x plus 63, just double check that, minus plus 40x plus 63. And we need to find the range for which is negative. So first of all, we need to differentiate this. I'm not worried about you differentiating normally, so I'm not going to really go into too much, but you just get 6x squared minus 42x plus 40. Now, this is a positive quadratic, And as I showed you the other night, it looks something like this. So if we're looking for the range of values for which it's negative, we're looking for anywhere it's below the x-axis. So we're looking for all the values here, and more importantly, we're looking for this point right here and this point right here, because anywhere along the x-axis here, it's going to map to a point on the quadratic or on the graph that's below 0. So all we need to do is find these 2 points. Again, all we're going to be doing is just doing the minus b formula again, because that's how you find the roots of a quadratic. So we'll have, once again, minus b plus or minus b squared minus 4ac, square root that, divide that by 2a. So in this case, we have 42 plus or minus square root of minus 42 squared minus 4 times 6 times 40, all divided by 2 times a, which is 6. And we get 2 values, one's positive, one's negative. If we fill this out, we're going to get for plus, we get 5.86, and then for minus, we're going to get 1.14. So if we look at the graph, we can say that this point right here on the left, which I'm going to call A, well, that's going to be equal to 1.14. And if we look at the second point, B, that's going to be 5.86. So anywhere in between 1.14 and 5.86, it's going to be negative. So we can say that x has to be strictly less than 5.86, and it has to be strictly greater than 1.14. Why am I using strictly and not less than or equal to? Well, if you use 1.14 and you were to plug it back into this equation right here, what you'd get is that you get a point on the line. So something like this is on the line, but right here it's on the line. So that means x would be equal to 0 and your y would be equal to 0. More importantly, your y is equal to 0. So that means that it's neither positive nor negative. It's positive technically, but 0 is a funny number, but it's definitely not negative. So we can't include that because in the question, we're looking for where f prime of x is negative. So question 6, it says differentiate f of x equal to 2x squared plus 4x with respect to x from first principles. First principles, it's not in your tables, you just have to learn it off. If you do a few of them though, over and over again, they get much easier. So it's simply f of x, then the next step is f of x plus h. After that is f of x plus h minus f of x. Then we do f of x plus h minus f of x, all divided by h, and then we take the limit as h goes to 0 of f of x plus h minus f of x divided by h. Same steps every single time. So if you just learn this off, it gets much easier. So yeah, just box that off. They're the same steps you follow every single time. So the very first step is we take f of x. So f of x is equal to 2x squared plus 4x, as it says in the question. Now wherever we see an x, we just put in x plus h. So it's 2x plus h squared plus 4 times x plus h. And if we go ahead and multiply that out, x plus h squared, well, that's equal to x squared plus 2hx plus h squared, and then we need to multiply that by 2. So it's going to be 2x squared plus 2xh plus h squared, and then we need to add on 4 times x is 4x, and then 4 times h is 4h. So we multiply that out, we're going to get 2x squared plus, 4xh plus 2h squared plus 4x plus 4h. Now the next step, we need to take this and we need to subtract away f of x. Just move that up slightly. So it's going to be 2x squared plus 4xh plus 2h squared plus 4x plus 4h. And then we need to put that in a bracket. And then we need to subtract off f of x, which was the very first thing, which was the original function. So we need to take away 2x squared plus 4x. You should always get some sort of cancelling going on here. So we can see a 2x on the left and the right hand side, so we can cross those two out, and there's also a 4x on the left and right hand side, so we can cross that out. So then this line is just going to be equal to, if I rearrange it, 2h squared plus 4xh plus 4h. And then everything else is gone. Next step, we need to divide this by h. So we have 2h squared plus 4xh plus 4h. Divide this by h. H goes into h squared h times, so we just get 2h, or it just cancels out that square. The h in the bottom cancels out the h in the 4xh, so then we just get plus 4x, and then the very final term, 4h divided by h, just goes 4. It's just 4. Now we take the limit as h goes to 0. So in this step, wherever I see a h in what I just figured out dividing by h, I just sub it in as 0. So it's 2 times 0 plus, there's no h in the 4x and there's no h in the 4. So this is just going to be equal to 4x plus 4. And then if you really want to double check, so this would be my answer. You can take f of x, which was equal to 2x squared plus 4x from the very first question. Just differentiate this normally. So I know that f prime of x is going to be equal to 4x plus 4. And you can see that these two things are the exact same. So you got 4 marks for that one. Now, this is an uncommon question, but it's important to understand it now, just in case anything like this comes up in the future. So it says, a rectangle is expanding in area. Its width is x centimeters, where x is a real number and x is greater than 0. Its length is always 4 times its width. Find the rate of change of the area of the rectangle with respect to its width x when the area of the rectangle is 225 centimeters squared. So if we draw this out, as you did the other night, we have a length here, which is 4x, and then we have our height, which is x. So I know that the area is equal to length by width, so it's going to be 4x by x, which is just equal to 4x squared. So I know that the area of this is equal to 4x squared. Now, find the rate of change of the rectangle with respect to its width x when the area of the rectangle is 225 centimeters squared. So because we have because we have a function for area, so if I have a of x is equal to 4x squared, it just means that whatever I choose from x, that's going to determine how much longer the length and width get for this thing. So it could be anything. As we done the other night, I know you picked out a few numbers. We just shown how the area increases or decreases depending on what area you choose. So we can treat this as a function of x. So first of all, I want to figure out what value of x gives me this 225 centimeters squared. That's just something you've been doing for a while. So you have 4x squared is equal to 225. How do I find x by itself? Well, I divide by 4, so I get x squared, which is equal to 225 divided by 4, and then I take the square root. So x is equal to the square root of 225 over 4, which simplifies down to 15 over 2. Or 7.5. It doesn't make a difference if you use fractions or not. Now the next step, I need to figure out the rate of change. So the rate of change is any function is what you get when you differentiate it. So if I take the function that I sort of created by timesing the length by the width to get the area function, I have ax squared, or ax is equal to 4x squared. Now if I differentiate this, I get a prime, which is the derivative of a, is equal to, differentiate 4x squared normally, I just get 8x. Now I want to substitute in 15 over 2 into my value of x, because that's how much this thing is changing by. So I'm only dividing this just so you can see that's like a step 1, step 2, step 3. Just because this is the kind of thing you'd be doing with every question. So if I take a prime and then I sub in 15 over 2, I'm going to get 8 times 15 over 2, which 8 times 15 is 120 divided by 2 is 60. So I get 60. And because this is a rate of change, we can then say that this is going to be 60 centimeters per centimeter squared. So when we have a value of 15 over 2, the area is changing at a rate of 60 centimeters. Depending on what value we choose is going to impact what this changes. So if we take equal to 1, for example, it would have a prime of 1 is equal to 8 times 1, which is just equal to 8. So that would be 8 centimeters per centimeter squared. And then as we increase it, it's getting bigger and bigger every single time. So Any questions on that, or you want me to explain it further, just let me know. So this question is something that you wouldn't have met yet. It's sort of towards the end of it when you understand everything. I know you've heard of point of inflection, or you call it the POI, and whatnot, but this is what it's going to be. So it says the graph of the cubic function p of x is shown in the first diagram below for x somewhere between 0 and 4. The maximum value of p prime, which is the derivative of p, in the domain is 1, and p prime of 0 is equal to minus 3, where p prime of x is the derivative of p of x. Use this information to draw the graph of p of x, or p prime of x, on the second set of axes below for x somewhere between 0 and 4. So I'll add in after this just me explaining what happens when you go from a cubic to a quadratic and why the roots line up with one another. So whenever you have a cubic function, a little space on here. Whenever you have a cubic function, any function whatsoever. So I'm going to draw this as a positive one, so it's going to look like something like that, and then let's do that as well. So that's just the cubic function. And I'm going to call this f of x. If I find the derivative of f of x, what I'm going to get is, first of all, it's going to be a positive quadratic, and it's going to look something like this. Make it a little bit bigger. Okay. And this is equal to f prime of x. So when you go from a function to its derivative, what actually happens is, if you look at the turning points of the cubic on the left hand side, we're going to have one turning point here, and we're going to have one turning point here. How do we find the turning points? Well, turning points have a unique property where the slope at the turning points is equal to 0, and they're the only points in which you can get the slope equaling 0 at this. Anywhere else, it's going to have a slope that looks like that, or even that, or anything like that. So that's how we'd find them. If you were asked for the turning points, you'd find the derivative, and then you'd equal the turning points to 0. But what you're actually doing, sort of without realizing it, is when you take the derivative of the cubic on the left and it produces the quadratic on the right hand side, the turning points equal 0 at the roots of this equation. So right here and right here. So if I call this point A and this point B, then the turning points of the cubic are going to happen at A and then some value of y, and then the second one is going to be at B and then some other value of y. How do we find that value of y? Well, whatever our x value is that we found by solving the roots of the quadratic, we plug that back into the function for the cubic, and then that gives us the y value. Another thing is, the point of inflection is going to be the midpoint between the highest, or between the two turning points. So if you look at the left hand side, we have one turning point here and another turning point here. Our point of inflection is going to be exactly the halfway point in between them. It also is when it changes from concave down, which is something like this, to concave up. And we know this because the arms of the one on the right hand side as I'm drawing now go up, so that's concave up, and the ones on the left hand side go down, so that's concave down. But it's literally just the midpoint between the two. If you were to draw a straight line between those 2 points, I know it's not really a straight line. Let me just do something like this. Like that. We see that there's a point here that it crosses over the blue line, and that is also going to be your point of inflection. Now, what is that for in terms of a quadratic? Well, if you look at it, the turning point is the midpoint between the highest and the lowest, or the lowest and the highest if it was negative. But it's also going to be the midpoint between A and B, which is this point right down here. And how do we solve this? Well, if we have the quadratic, so if we have f prime of x, if we find the derivative of f prime of x, we're going to find f double prime of x, and then we equal that to 0. It's going to tell us when the slope equals 0 of the quadratic. So if we know where this slope is equal to 0, we'll be able to find the x value associated with this, and then if we sub this value of x, because it's only x, well, there's a y value as well, but we find this x value, and we plug it back into f of x, it's going to give us this point right here. Because it's halfway between a and b, it's halfway between the highest and the lowest, so that's our point of inflection. Back up to this question though. So, we know that if we go from a cubic and we differentiate it, we have to get a quadratic. So first of all, we know it's going to be a quadratic. So we know that p prime of x is quadratic. We also know that because p is negative, because this is going down, we know that it's going to be a negative quadratic as well. And now we can use those other things that I was just talking about there. So if we look at the turning points of the cubic, they're going to be the points of intersection of the x-axis of the quadratic. So it's going to be the roots of the quadratic. So if we look at the turning point here and we just drop it straight down, we know that it has to cross at x equal to 1, and the exact same thing for the highest point, or the other turning point, it's going to cross at x equal to 3. We also know that the turning point of the quadratic is the point of inflection, or the POI, of the cubic. Again, we'll go over this in more detail. So if we know where the point of inflection is, we know that that's going to be the turning point of the quadratic. So the question also tells us that the highest point is going to be equal to 1. So it's logical to assume that the highest point of this is going to be somewhere between 1 and 3, and if you just go across it, you'd naturally assume it was 2. But if we look at the point of inflection of the cubic, so we have one turning point here, one turning point here. One's at the point x equal to 1, and the other one's at x equal to 3. So then the point of inflection happens at 2, because it's halfway in between them. Again, if we just drop this down, we can see that the highest point is going to be right here. Finally, the question tells us that when we have p prime, so when we sub 0 into the quadratic equation, it comes out as -3. So at the point x is equal to 0, we have y is equal to -3. And then because quadratics are symmetric, we know that it has to also cross through this point 4 here. So in the end, what we're able to do is draw the picture of this quadratic, which is going to look like this. So without actually having to differentiate it, because we have a picture of the cubic, we're able to just look at it and tell all these different things about the quadratic. We know that the turning points are going to be where the quadratic crosses the x-axis. So turning point is at 1, so that means it crosses 1. Turning point's at 3, so that means it crosses at 3. We know that the point of inflection, which happens halfway between 1 and 3, which is 2, is going to be the highest point, or the turning point, of the quadratic. And then we know, because it told us in the question, that p prime of 0 is equal to -3. It gave us this point here, so then we're able to infer, because it's symmetric, that it happens at this point here. So I hope that helped. Any other questions, just give us a shout and I'll get back to you as soon as I can. Okay, so we're going to have a look at question 4 now. So it says the diagram below shows two functions, f of x and g of x. The function f of x is given by the formula f of x is equal to x cubed plus kx squared plus 15x plus 8, where k is an integer and x is a real number. Part A. Given that f prime of 3 is equal to -12, show that k is equal to -9, where f prime of 3 is the derivative of f of x at x is equal to 3. So, first of all, we're just going to write out what f of x is. So we know that f of x is equal to x cubed plus kx squared plus 15x plus 8. And then it tells us that f prime of 3 is equal to -12. So when I find the derivative of f of x and I substitute 3 in for all the x values, it equals -12. So when I find the derivative, I'm going to have this. So you got this last night, or the last night. F of, prime of x is equal to 3x squared plus 2kx plus 15. So when I substitute in 3 for all the x values, the only remaining variable is going to be k, because I'll have 3 subbed in here and 3 subbed in here. And this whole thing has to equal -12. So if I find f prime of 3, what I'll get is 3 times 3 squared plus 2k times 3 plus 15. So this is going to be equal to 3 squared is 9, 3 times 9 is 27, plus 3 times 2 is 6k plus 15. Simplify this slightly, I'll get 6k plus 42. Now, I also know, as I said, that f prime of 3 is equal to negative 12, as it says in the question. So this whole thing has to equal to minus 12. And now I just simplify again. Minus 42 from both sides, I'll get 6k is equal to minus 54. And if I divide both sides by 6, I get k is equal to minus 9, which is what it told me in the question. So I know I'm right. Now, question 2. It says, the function g of x is the line that passes through the two turning points of f of x, which is equal to x cubed minus 9x squared plus 15x plus 8, as shown on the previous page. Find the equation of g of x. So if you weren't able to get part A, it doesn't really matter because it tells us it tells us what f of x is equal to, and all it did was substitute minus 9 in for k. So, how do we do this? So it tells us that this line, it's kind of similar to the last question we done. So this line passes through the two turning points of g of x. So if I can find the two turning points of g of x, it'll give me a point here and a point here. And that's all I need to do to make an equation of the line. Because with those 2 points, I can use my equation, my slope equation, which is the y2 minus y1 divided by x2 minus x1, to find the slope, and then just use one of those points, and I'll be able to find the equation of g of x. So, g of x is the line, f of x is the cubic. So, f prime, or f of x, I'll rewrite out, is equal to x cubed minus 9x squared plus 15x plus 8. Turning points are located where f prime of x is equal to 0. Whatever value of x I get, I substitute that back in to f of x, and that'll give me the y value. So let's go ahead and do that. So I need to find f prime of x first of all. So that's going to give me 3x squared minus 18x plus 15. I can make this a little bit easier by dividing everything by 3. So I get x squared minus 6x plus 5. Now, you can minus b this, and it'll give you the exact same answer as the factor method. So the factors of x or x squared are going to be x and x, and the factors of 5 are just 5 and 1 because it's a prime number. I need to come up with a combination that when I multiply 5 by 1, so 5 multiplied by 1, I'll get 5, and when I do 5 plus or minus 1, I'll get minus 6. So you can already see the only way to get a negative number is if one of the negative, or if one of these numbers are negative. But if I do minus 5 plus 1, I'll get 4, and if I do minus 1 plus 5, I'll get 4. So it has to be minus 5 minus 1. So I'll have x minus 5, x minus 1. I can double check this if I want and multiply it out. So I'll have x by x gives me x squared, minus 5 by minus 1 gives me plus 5, and then I have minus 5x minus 1x, which is just equal to x squared minus 6x plus 5. So I know I'm right. So I know that x minus 5 equals 0, so x is equal to 5. I know that x minus 1 is equal to 0, so x is equal to 1. So because I have these two, I'm going to take this value, and I'm going to substitute them back in here. And that'll give me the y value of the turning points. So if I do f of 1, that's going to be equal to 1 cubed minus 9 by 1 squared plus 15 by 1 plus 8. Just stick that all into your calculator. So what you get is 1 cubed minus 9 by 1 squared plus 15 by 1 plus 8, which is equal to 15. So this is the turning point 1, 15. That's the coordinates. Do the exact same thing for the other value. So if I find f of 5, which is equal to 5 cubed minus 9 by 5 squared plus 15 by 5 plus 8, stick that all into your calculator. You get minus 17. So therefore this is the point 5 minus 17. I'll go back up and just write them in. So I had this point here was 5 minus 17. And this right here, and this was the point 1, 15. So now I need to use my slope formula to get the slope of this line. And then when I find the slope, I can just substitute everything back into the equation of a line formula. So my slope is going to be y2, so minus 17, minus y1, minus 15, over x2, which is 5, minus the first one, 4. So this comes out to minus 32. Sorry, minus 1, sorry. Minus 5, minus 1. So that I get minus 32 over 4, which is just equal to minus 8. Now I can just choose either point and use this as my slope. So I'll get y minus y1, 15, is equal to minus 8 times x minus x1, which is 1. So I get y minus 15 is equal to minus 8x plus 8. I'm going to bring the 8 over, so I get 8x, the y stays there, plus y, and if I subtract 8 from both sides, I get minus 23 is equal to 0. So this right here is going to be the equation g of x. I like this question because it makes you think about what happens when you find the derivative of a cubic. Well, it's going to be the quadratic. And if I were to graph out what that quadratic was, it would have looked something like this. That one over, maybe there, and there. And what this would have shown me is that the roots of the quadratic, so this point here is one of the turning points, and the other root is the other turning point. And then if I substitute them back into f of x, or the cubic, it'll give me the y value. So it'll go out here and give you the y, and the same thing, it'll come all the way over here and give you the y value. I'll get rid of those though. Any questions, just let me know, and I'll answer them as soon as I can. So it says C, show that the graph of g of x contains the point of inflection. So the point of inflection is equal to the second derivative of f of x and equal that to 0. It's also the halfway point between the two turning points. So you can find the midpoint between 115 and 517 and then show that and get that point. And then if you substitute that point into the equation of g of x, which is right here, it'll give us the answer. So I'll do it the algebra way first, and then I'll show you the other way. Or I'll do the calculus way first and then show you the coordinate geometry way. So we had f of x is equal to, let's grab that again, x cubed minus 9x squared plus 15x plus 8. So if I find the derivative of this, as I've done before, we do f of prime of x is equal to 3x squared minus 18x plus 15. And if I find the derivative of that, I get f double prime of x, which is equal to 6x minus 18. I now solve this where it's equal to 0. 6x minus 18 equals 0. So a 6x is equal to 18. So x is equal to 3. I now substitute 3 back into f of x. So if I do that, I do f of 3, which is equal to 3 cubed minus 9 by 3 squared plus 15 by 3 plus 8. I'll bring this down just so I have more room for the next step I'm going to show you. And this gives me the point minus 1. So therefore I have the point 3 minus 1. Now if I substitute back this back into the equation of the line that I figured out in the last question right here, I should get the right answer. So let's see if I was right. So we have 8x plus y minus 23 equals to 0. If I use my x value of 3 and my y value of minus 1, I'll end up with 8 by 3 plus y is minus 1 and then minus 23. 8 by 3 is 24, minus 1 minus 23 is equal to 0. So you can see if you type that all into your calculator, or when you do minus 23 minus 1, you get minus 24. I get 0 is equal to 0. So therefore, g of x contains the point of inflection. So that's one way of doing it. I'll make there's a bit around in there. So the other way you can do it, if you don't want to do the calculus way, is to just find the midpoint between the two turning points, and then you should get the point 3 minus 1 and then substitute it back in. So to find the midpoint, we're just going to have to use the midpoint formula. So I need to take my 2 points, which I figured out in the last question. So 1, 15 and 5 minus 17. So I have 1, 15 and 5 minus 17. And then my midpoint formula is x1 plus x2 divided by 2, y1 plus y2 over 2. So if I use this, what I end up with is x1 is 1, and then I add on my x2, which is 5, divide that by 2. Do the exact same thing for the other point. So I've 15, and then I minus 17 because it's plus minus 17. Divide that by 2. Figure that out. 1 plus 5 is 6. Divided by 2 is 3. 15 minus 17 is minus 2. Minus 2 divided by 2 is minus 1. So you can see I got the exact same point as I did before. So then it would have been 8 by 3 plus minus 1 minus 23. Yep. Is equal to 0. And then the same thing. 24 minus 1 minus 23 equals 0. So then you just get 0 is equal to 0. So you can do either point, but I really like that question because it makes you understand your basics. I know you haven't covered them all yet, and it goes to show you don't need to know any other rules for this question. All you needed to be able to do is differentiate regularly, but it's your understanding of what actually happens in differentiation and calculus that really matters here. Obviously, I'm going to drill into you product, quotient and chain rule, and then when we do integration I'll drill that into you as well, just because they're really important and you need to know them, because this is only a 25 mark question, but you can see how easy it is to pick up 25 marks if you just understand calculus. But anyway, we'll deal with that when we get to it. I'm happy with how you're getting on so far, so I'm not really going to be going into any more details. So any questions, just let me know. Any questions before next week, just let me know as well.